Today we are mostly focusing on L2 non-domestic, and the session's purely an overview. This session doesn't count towards L2 accreditation, upgrade, anything like that. It's purely an overview. But I will cover how virtual environment users and CIBSE members can upgrade their accreditation with us, and hopefully answer any questions that you've got on that. So following this brief introduction, we will go through and look at what's happened. I want to look at the changes, the upcoming changes, in the context of what's happened with the regs since 2002 and what direction Part L may take in the future. I'll also touch on some of the tools that we have incorporated within the software to help to demonstrate compliance. Okay, so I wanted to just look at a sort of brief timeline. I have taken this from the UK GBC Building Zero Carbon report, which was published in February this year. So you can see since 2002, you know, we've started off with quite significant reductions, and that's been achieved till now. Sort of plateauing a little bit with the upcoming regs in April. You know, I think in 2006 we sort of introduced L1A and L2A for new build, L1B and L2B for existing buildings. There was the introduction of SBEM for non-dwellings, and a single method of compliance through 5 criteria. And just running alongside that, obviously, we have the Energy Performance Buildings Directive, which introduced EPCs to the UK in 2008. So, in summary, and I'm sure that most of you will already know these highlights, what I've basically done is just taken the headlines from the NCM Modelling Guide. Of course, the approved document can be obtained from the government's planning portal. As with the 2010 regulations, the 2013 notional building directly determines the target emission rate for your building. Specifications for notional buildings are generally much better than minimum requirements, and this is something that we always emphasise when we're talking about compliance, because it's understanding the notional building setup and parameters is key to your build, or getting your actual building to pass. A notable addition in this version of the regs is a summary of the key characteristics of the notional building, and I'm going to touch on that in the next slide. And the notional building, if we go back to the timeline, has improved by just over 50% since 2002. Sorry, 50% since 2006. So overall, the specifications are strengthened to deliver an aggregate 9% saving in carbon across the non-domestic building mix relative to L2 2010. There is an uplift by building type, so warehouses 4%, deep plan air conditioned offices 12%, retail warehouse 8%, shallow plan offices 13%, and so on. Another sort of change in this version of the regs is that there will be 4 classes of notional building. So notional building zone types, or a side lit, which is heated only, side lit, heated and cooled, top lit and unlit. And also in the notional building we see the air permeability now subdivided by building size. So again, when we come on to the next slide, we'll actually look at what that means. And the window U value reduced from 1.8 to 1.6 generally. Criterion 2 allows for a little bit of leeway. So in buildings with high heat gains, the case can be made for less demanding area weighted glazing U value, because obviously that impacts your cooling loads, reducing that U value. No significant changes to criterion 3. And the non-domestic compliance, there's new standards for chillers, fan coil units, lighting. Again, just come on to that in a second. So, yeah. So basically this is the table 5 summary of the notional building specification. So we've highlighted there what we see as the main changes. So you've got your window U value dropping to 1.6. You've got your lighting efficacy from 55, to 60 lumens per circuit watt. You've got the air permeability, so depending on the gross internal area of your building, that determines what the air permeability figure that's set in your notional building will be. Sorry, there's the lighting lumen per circuit watt is going up to 60. And then we're adding in controls as well, so occupancy and daylighting controls in the notional building. Okay, so this is really useful. This is something that, again, we would recommend that you memorise, commit to, or at least be very familiar with, I would say. Okay, so with that as well, from our sort of initial studies, it's looking like there is less scope for conventional rescue measures such as good lighting control without recourse to renewables. Commercial offices and other building types will require significant improvement in lighting efficiency with increased use of daylight, therefore more use of dimming and or new lamp technologies. And being careful in the selection of your systems, because auxiliary energy is a significant proportion of the energy consumption. So you've got to consider the trade-offs between increasing fan energy as well as reducing cooling loads. Okay, so 2013 regulations is a waypoint. It's not a destination. We are on the march to zero carbon. The 2013 budget reaffirmed the commitment to zero carbon new homes from 2016. We're also committed to zero carbon non-domestic buildings for new build from 2019. And this diagram, again taken from the UK GBC non-domestic zero carbon task group report, sort of shows the hierarchy. So also we've got the Energy Performance Building Directive, as I say, requiring near zero carbon or near zero energy from 2020, and it's 2018 for public buildings. The building regs is considered a successful mechanism to reducing carbon. That the report, the UK GBC report, states that DEC estimate that together Part L 2002 and 2006 saved 8.3 terawatt hours and 1.9 megatons of carbon by 2010, which was nearly a quarter of total savings from all energy efficiency improvement programmes and policies in the public and private sector. So it's seemed to be, as I say, a successful mechanism, and building zero carbon into, the way that we currently tackle the regs is perceived to be the way forward. I need to say, so in the UK, we're kind of leading the way. If the government does respond to the current lobbying to recommit to the 2019 zero carbon non-domestic new build target, then in the UK we have an opportunity to sort of take the lead in that, and with other countries looking to follow our example. However, when we look at buildings in use, we are still some way off achieving low carbon before we even get to zero carbon or near zero carbon. There is a lot of work to be done. The industry in recent times, I would say, appears to have woken up to what we call the performance gap. This diagram is taken from a Carbon Trust report, which is published in April 2012, and it's basically taken 28 case study buildings, so all different building types, and they reckoned even with detailed modelling and benchmarking, the gap between predicted and actual energy consumption still averaged about 16% across those 28 buildings. So according to the report and the diagram shown here, there are many factors that contribute to that discrepancy or the performance gap. And the NCM is one of those national calculation methodology. It's never meant to be anything more than a theoretical exercise. And the industry's now taking that on board much more with the realisation, I think, by building owners and operators. Now that EPCs have been in place for a few years, there is a much greater awareness between your rating or your Brickell document, kilograms carbon, and the real situation of the operational building. So the report does suggest that the design team should begin to consider total energy consumption rather than the more typical approach of focusing on complying with Part L, and then it's important to have an individual with a long-term involvement in making sure the building is low carbon in operation, and make someone responsible for this throughout the life of the building. So this is where we see this soft landings element coming into play, and you probably know the government has implemented the soft landings framework as part of their overall BIM strategy, and it's all about reducing carbon over the life of the asset, or in their case, the multiple assets. So the report does highlight the importance of predicting performance and how difficult it can be to accurately predict performance of buildings. And it also suggests that likely performance is predicted at various stages, and then ensure that it's monitored in operation to allow fine-tuning and energy monitoring and targeting, if you like. It also mentions on refurbishment projects, the process of developing predictive models results in a clearer focus on in-use performance. Okay, so it kind of, for me, sets out what the sort of ideal scenario is. So I think we, IES, that's definitely a direction that we are taking. We're talking about real building energy modelling versus compliance. So taking the NCM sort of out of the equation, if you like. I mean, yeah, of course we need to do it. It's a legal requirement, but it doesn't give a very accurate picture of how the building is actually performing. It doesn't take into account plug loads, and as we saw here, the extra occupancy, extra operating hours, quite a common scenario, inefficiencies, and then special functions. Obviously, there may be things, especially over I keep saying the life of the building, but things do change as well. So what we are suggesting and what we are aiming for and working for is to enable the compliance model, as is, with all the NCM template data assigned to it, to be more easily become a sort of real building example. And I mean, the key difference there is the systems, how the systems are modelled. I think I do talk about that, yeah. So we've got Apache systems versus Apache HVAC. Now, okay, I have just said that how the building is actually used, occupancy profiles, occupancy hours, those sort of things have an influence. The biggest, I think, factor which is different on day one is the way that the systems are modelled for compliance, which is using Apache systems, versus how they are set up in reality. And we would use Apache HVAC to more accurately recreate that. So with Apache systems, we've covered this in other sessions before, but the system efficiencies are approximated. It's okay for maybe early stage analysis, and obviously for demonstrating compliance from the early stages. But once you get into the detail, and again, in sort of existing buildings, we have a lot more information about how the systems are actually set up and how they're actually running, how they're controlled, and how that impacts on the energy consumption. And of course, you know that for LEED and Green Star, this level of detail in the systems modelling is a prerequisite. So we are, I guess, some of you on the session will already be involved in using this sort of detailed energy modelling approach for projects, maybe in the UK, but certainly out with the UK. And what we can also then start to do, once we have that detail in there, is we can start to look very seriously at how the design intent, if you like, compares with the reality. So we can start to pull the real measured data from the building back in and look at the two side by side. Okay, so as I say, that's quite a big step to go from Apache Systems up to Apache HVAC. Is quite a, you know, it's quite drastic, and we have been working in recent times to try and make that a much easier proposition. So we've got some auto-sizing tools, for example. We've got things like multiplexing, prototype systems. We've got enhanced chiller modelling. One of the other things that we have in particular related to compliance are the navigators. So these navigators take you through step by step every task that needs to be completed within a compliance assessment. So you go through step by step and you can then tick the various tasks to highlight when they've been completed. You can add notes to these so you can keep track of inputs and assumptions perhaps that you've made as you go through and set up the model. Yeah, we see this as being extremely beneficial. And the other benefit from the navigators, as you probably know, is the additional reports that you get out. So we have two reports. One is a key input comparison report, which basically summarises the actual and notional inputs, highlighting elements where the actual performance is poorer than the notional. So going back to my original point with regard to changes in the regs, if you understand and can clearly see without too much legwork, because this is just it's another output basically of the work that you've done. You don't have to take all this information out to Excel and process it yourself. So you can see quite clearly where you're performing not so well, and you can make decisions on that basis about what changes need to be made. And then taking that a bit further, we have the design options report. So that actually identifies the largest contributors to the carbon emissions and the elements that exceed the notional building carbon emissions. So here we have, the sort of headline here, which is our actual heating, domestic hot water, cooling, auxiliary energy and lighting, compared directly with the notional. So you can see straight away at a glance what are the dominant factors. And in this building, we're probably saying, well, definitely the heating, cooling and the lighting. So those would be your first protocol in terms of making improvements to that building to make it pass. Okay, so as I said, we are running a roadshow for those that are already accredited using our software. This will enable you to upgrade your accreditation to the new regulations. So you'll need to do that in order to upgrade your accreditation, as I say. So there are currently, I think, 10 dates in the calendar. The early bird sign up has been and gone. We were sort of pushing that at EcoBuild, but we're running it in conjunction with CIBSE. So it's a half-day CIBSE session in the morning and then a half-day IES session in the afternoon, and it gets it all done and dusted in one day. There's no need to, sit an exam per se. It's just sitting in a sort of more detailed training session. And all of the detail around what I've been talking about so far obviously will be looked at in the roadshow. So what they've done is to take a number of different buildings and look at the implications of the changes in the regs on those types of buildings, and they will highlight the sort of key considerations for the different types of buildings, key issues that have cropped up. So now, all I can really do now is give you a quick tour around. This is a beta version of the software. Now, in fairness, the user interface doesn't change that much. The key things for me to draw your attention to, the key changes will be, in your drop down here, you'll have L2 2013, okay? You will also have L2 2010. So although I was saying that you do need to purchase a separate licence for 2013, they will appear in the same interface. So it's not like when we had the delay between the 2006 and 2010, and you had to run two versions of the software and maintain two versions of the software. It's not the same as that. So you can just switch into Part L2 2013. Okay. I mean, I would suggest that the user interface being largely unchanged is a good thing, because it means that sort of awareness raising, as the learning curve associated with that is not going to be massive. So you've got the new regs mode there. When you go into building and system data, you've got a new, what's called an EPBD recast. So that relates to the building and systems, obviously. So in the design of this building, please confirm by ticking the box that consideration has been given to the use of alternative energy systems as defined. So it's actually consolidating some of the initial steps that were made in 2012 towards alternative systems, what they're called. So that I think the requirements around that are still in development, but we start to see these sort of additional things creeping in. In the building details then, you've got has Lenny lighting calculation been carried out? This is a lighting energy numerical indicator, so it's an alternative route to compliance. So the question was, does it appear in the software? The answer is yes, but I think the calculations obviously have to be carried out elsewhere. And I'm not sure, I know you're going to ask me, but I'm not sure whether and how you do that in the software, but I will certainly find that out. All the questions that are asked today are recorded, and we'll publish the responses to those questions. And these things, again, as I say, will be picked up and incorporated into the roadshow, which is happening starting on the 10th of April. So, I mean, that's it really in terms of interface. A lot of the other stuff happens under the hood, as it were. The fuel emission factors change, and they will be applied based on the regulatory mode that you're in. So if it's 2010 or 2013, you'll have different carbon emissions factors. And the activities are largely the same, although there are some minor corrections, but the list of activities stays the same. Okay, so there's not any major changes there. And that's it really. I did do the model that I'm showing there in the background, this school. It's quite a big school. I did, in this beta version of the software, I did an analysis just to see how the two looked. So originally I did make it naturally ventilated, and I just looked at the differences between the 2010 notional building and the 2013, which, as I say, is reflected in that summary table within the modelling guide. So, I mean, while the intention is to reduce the TER by 9%, or 9% aggregate reduction, the likelihood, well, the reality is that the actual level of reduction varies depending on the type of building, etc. And based on the 2013 notional building attributes, we have done some early testing to better understand the impact of that on the TER and the end energy uses. Okay. So this is, as I say, a naturally ventilated school. You can see that there's no demand control ventilation. That's only applied to mechanically ventilated buildings. There are occupancy sensing controls though, and we talked about the lighting efficacy, the air permeability and the glazing U value changing. So they're the kind of key things. I did then make some tweaks to that, and I did introduce some cooling in certain areas and ran it again. So you note here that for 2010 to 2013, a number of the elements are actually going up in terms of the kilograms carbon. So with the lighting, and I think this is something that you will see in quite a number of designs, I've added in the occupancy sensor controls and the improved lamp efficacy, but the inclusion of a maintenance factor on the 2013 notional building lighting results in an increase in lighting energy, okay, compared to the 2010. And the cooling's slightly higher as well, and this is kind of a result of the reduced air permeability and the improved window U value. So, like I said, there's a bit of leeway in buildings with very high heat gains to use a different area weighted U value calculation, and the fuel factors are different. So that means that the overall is, but it's not massively different. It's like 4% increase. So a bit counterintuitive, I felt. I thought it was going to be tighter, but it's not. And just to sort of sum that up then, I mean, you'll see a lot of examples of these if and when you attend the roadshow. So the lighting and the auxiliary ventilation in this particular example are the key areas that I've got to try and address.